we are to find the derivative of y equals x plus 1, then x plus 2, we are using what we call the product rule. So the product rule is what we are using today. The product rule is a rule where you differentiate one and hold the other. All right, then we differentiate the other and hold one. So that is what we have today. So that is product rule. So in product rule, we are going to keep one, differentiate the other, then add it to keeping the other and differentiate the first one. So for instance, in product rule, we are going to hold this one and differentiate this. Then afterwards, we'll now hold this one and differentiate this. Then add the sum, add the both together, and that gives us the product rule. Okay, please stick to the end so you can be a beneficiary of the November special, which we have for everyone, okay, who has been encouraging the growth of this channel. All right, so here we have to find derivative, and derivative is this. We are going to use this here. We are going to have u, let u equals, let u equals x plus 1. Okay, so if u equals x plus 1, then what we have is du, okay, du dx. Du dx will be the differential of this. So du dx is going to be 1. If we differentiate x, we are going to get 1, right? So that's what we're doing. We are differentiated x plus 1, so we get 1. So differential of a constant is 0, and differential of x is 1. So we have gotten this first one. So, and the second one is v. Then let v equals x plus 2. So v equals x plus 2. In this case, we are going to get dv dx. So dv dx is going to be the differentiation of this one too, which is 1. So we have 1 here. All right, so this is what we have here, right? So, and we are now going to use this formula. Let's look at this formula. The formula is if we have y equals uv, in which case the first one here is our u, while the second one here is our v, then it implies that our dy dx from product rule is going, we are going to keep u, then dv dx, then plus v and du and dx. So this is what we have. All right, this is what we are going to have here. Here we keep the v, differentiate, we keep the u, differentiate the v, then plus we keep the v and differentiate the u. Now we are going to pick each of them. Okay, each of them are represented here. So we are going to have our dy dx, which means that our dy dx is equals to u. Okay, u is x plus 1. So we are going to come here and write x plus 1 inside the bracket, x plus 1 inside it, then dot dv dx. So our dv dx is 1. So we are going to write 1 here, that's 1 plus, okay, then we'll come here, our v is x plus 2, so we are going to write x plus 2 here, x plus 2, okay, that's what we're going to write here, and then du multiplied by du dx. So what is du dx? This is du dx, and that is equals to 1, so that is dot 1. Please do not forget the dot here represents, the dots we have here represent product or multiplication and not decimal point. Please do not forget that. And when we go ahead and simplify, 1 multiplied by this bracket opens the bracket and give us same result without any change at all. So we have x plus 1. Then here we have x plus 1, x plus 2 multiplied by 1 will give us x plus 2. So we have x plus 2. All right. Then when we collect like terms, when we take the like terms, okay, x plus x, right? Bringing like terms together, we have x plus x, then plus 1 plus 2. All right, so this is what we are going to have when we add x plus x together. When we bring in the x and total the x, we are going to have 2x. So we are going to have 2x. Then when we add 2 to 1, we are going to have 3. So this is dy dx, and I hope this is well understood. If it's not well understood, please let me know through the comment section. Okay, just put in your suggestion. All right, put in your suggestion for your comments, your likes, and I'm very happy. Please, today is November special, this mathematical weekend, November special. So please do well to always join us every Saturday on our mathematical weekend. But today is November special, and I do hope that you are deriving value in my video. And for those of you that have been encouraging the channel, I've been making the channel to grow. Because of you, the channel has been growing. So please do well to keep joining us. Today is November special. We have something special for everyone who have been joining the channel through live stream and other means too. Okay, you have been watching my videos. I appreciate you for that. There's something special for everyone. Please do well to join and keep joining. Okay, stay till the end. There's something special for you that I'm going to give to everyone who have been here and who will be here today. All right, so thank you very much. Now I'm going to go back and review what I've said so far. Okay, what I've said so far. Here, we are giving the first question here to find the derivative of y equals x plus 1, then x plus 2, and we have to apply the product rule of differentiation or differential calculus. Now, the easiest way to do it is simple. Just represent one of the term by u and the other by v. So the first one is u and the second one is v. All right, so please, we're sorry for the noise. There is a fellowship going on here, and that is why we have this interference. Please, I'm sure you can hear me very well. Right, so this video has to be held to make sure that you have your field for the weekend. So here u becomes x plus 1, u becomes x plus 1, and u becomes x plus 1, and v is x plus 2. Please tell them to stop making noise. They are disturbing us. Okay, so u is x plus 1 and v is x plus 2. All right, so please, u is equals to x plus 1 and v is x plus 2. What we are simply going to do, we are going to have something like this where y equals uv, 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 uv. So u is x plus 1 and v is x plus 2. So let u equals x plus 1. All right, then we are going to differentiate u with respect to x plus 1, and that is what we have done here. And when we differentiate u with respect to x plus 1, with respect to x, we are going to get 1 here, and that is the differentiation of u. Then we take the second one, v is equals x plus 1. Okay, since v is equals to x plus 1, we'll differentiate v with respect to x. We'll also get 1 here. So the implication is that we can liken this equation like this. We can bring it this way to look like this particular one. So what it means is that we are going to use this formula. So in this case, dy dx equals u. Okay, u, just leave this u alone, rewrite the u, then differentiate, multiply by the differential, okay, by the differential of v, dv dx, plus, then leave the v and multiply by the differential of u. Okay, and that is what we have here. This is u left here, then dot 1 plus, then here we leave the v and differentiate and multiply by the differential of u. Remember, the dot here is not a decimal point, but it is a product. It is a times, a multiplication sign. All right, so, and when we multiply by 1 on each of the sum on each side, it's just the same. Okay, so 1 doesn't change anything. 1 times the bracket remains the bracket. Okay, then we just have to add up. Adding up here gives us x plus x, which is 2x, and 1 plus 2 equals 3. So this is what we have today. Thank you for coming to AZ Science TV Mathematical Weekend on AZ Science TV. And I hope you have subscribed. Please, in case you have not subscribed, do well to smash the subscribe button so you can keep being a part of this wonderful channel, so you can grow with us as we move together to a greater height. All right. So thank you very much for being here. You will find the subscribe button just down below. You are going to see it. Also click on reminder so that whenever we are coming on live video, you will be there to be a beneficiary uh, uh, of our videos and tutorials online. We are very much committed to online live stream because we believe that is where students learn more on a live video. So thank you very much for being here. And let's look at the second question for today. Now, this is the second question for today. We are given here that if y equals x sine x, then we have to find the y dx. So how do we get this done? It's quite simple. Here we take our u to be x and our v to be sine x, right? So here we write let u equals x. So if u is x, we can differentiate u with respect to x, and that is du dx. Du dx is equals to 1. When you differentiate an expression with respect to the letter, you are going to get 1. Okay, so that is what we have gotten for u. Then for v, let v equals sine x. Let v equals sine x. So v equals sine x here. So we can differentiate v, and that is dv dx. So this is what we have when we differentiate sine x. Sine x becomes cos x. Okay, yeah, this is what we have when sine x differentiated. Okay, we have cos x. So this is the differential of sine x. So we can now apply, don't forget, we can apply our rule. The rule is if y is equals to uv, if y equals uv, it means that the y dx, dy dx is equals to u dv dx, then plus v du dx. So this is what we have. This is what we're going to have. Okay. If y equals to uv, the y dx becomes keep the u, differentiate the v, then plus keep the v and differentiate the u. Okay. Now let's go and do our substitution from here. Our u is equals to x, right? It's written here. Our u is equals to x. So we are going to write x, then dot. What's our dv dx? So we go to dv dx. This is dv dx, and that is cos x. So we are going to write cos x, then plus, okay, plus. Then we go to v. What's our v? Our v is sine x. So we are going to write sine x here. Dot. Then what's our du dx? Our du dx is 1. So dot 1, okay, and dot 1. So that's what we have here. So we are going to simplify now. X dot cos x is x cos x. So we're going to have x cos x, then plus sine x. So this is the value for the differential. Okay, this is what we have when we differentiate this. Okay, This is exactly what we're going to get, and I hope we're following this video. I appreciate the fact that we're here, and we want you to always be at your best. And if you're a teacher, well, please link us to your students, share this video to your students, and I can assure you your student will keep deriving values. If you have taught this topic and the children seems not to understand it properly, please, it is high time the children join us and let's see how we can help them out to clarify what you have previously taught them in the class. Okay, so thank you very much for joining, and if you are joining us and you have not subscribed, please do well to smash the subscribe button so you can be a part of us. Today is mathematical special edition of mathematical weekend, so it's special for every one of you. So the topic is calculus, and we are focusing on differentiation, and the method we are looking at is the product rule. So this is the method of differentiation we are looking at today. So when we have product of two terms, how do we differentiate it? It is by product rule. Okay, we can use product rule, and that is what we are using today. So please, let's go over to what we have learned so far in this question. The, the question before us right now is x equals sine x. Okay, and we are told to find dy dx, which means we're actually told to differentiate y with respect to x. And how do we begin? There's no way we can do it except we bring in the product rule. Okay, so the product rule states that if y equals u v, if y equals u dot v, then dy dx is you are going to repeat the u here and differentiate v, okay, with respect to x plus v, keep the v, then differentiate the u with respect to x. So in that case, we have our u here, u is equals to x, and our du dx is the differential of u with respect to x, and that gives us 1 here. Then we have v, and v is equals to sine x. Okay, the second term is v and equals to sine x. And when we differentiate v with respect to x, we'll get cos x. Now it is time for us to apply the formula, which is the product rule. The product rule here, we have our u, which is x. So our u, which is x, is here, dot dv dx is cos x, right? So this is dv dx, which is cos x here, then plus this sine x, so which is our v is sine x, and this is sine x right here, dot du dx. So du dx is 1 here, that is dot 1. Please do not forget, as I've reminded us before, this dot here is not decimal, but it represents product or times or multiplication. That is what this dot here represents. And when we multiply these two terms together, x and cos x, we are going to arrive at x cos x, then plus. When we multiply here too, we are going to get this. So this is the solution to the second question for this morning, mathematical edition, EZ Science TV, November special. So I have something special for everyone who have been patronizing this channel just for the crave for knowledge. You want to learn, you want to be better. I appreciate the fact that you're always joining me. Okay, thank you very much for being here, and I do hope that you keep being with us so that we can all grow together. Thank you very much for being here, and for those of you who just want us to be at our best and are doing your best to make sure that we move to that level, I appreciate you. Please keep sharing and liking and commenting. You can suggest, you can ask questions, and if there are better ways you want us to function, please go ahead and let us have it. Okay, we are more than happy to have you being a part of this channel. We want this channel to be at the best, and only you can make it possible. All right, so thank you very much for that. So that is that for this particular question. So let's quickly solve the next question for today's class. So this is the third question for today. We have a third question. Third question today. We have a third question right here today. Right. So here we are giving y equals 3 x raised by 6 minus 10 in the first bracket, and here we have x raised by 4 plus 30. So these are the terms we have, and you can see that are multiplied by each other. So we have to use the product rule to solve this problem today. So what we are simply going to do is that we're going to have our y here. Here becomes u, and yes, v. Therefore, we write let's u equals 3x squared. 3x raised by 6, 3x raised by 6 minus 10. Okay, now we are going to differentiate this. The u dv will differentiate with respect to x. That's du dx, right? So when we differentiate this, we are going to have 6 times 3 here is 18. Then this is x. Okay, x, this is 6 minus 1 here. This, take away 1 from here, we have 5 here. So here is 0, because when you differentiate a constant, we get 0, right? The differential of a constant is 0. So we are brought in du dx. Then our v, we are going to get v equals, look at our v here. V is x raised by 4 minus 30. Minus 30. So this is our v. Then we are going to differentiate v with respect to x. So which is dv dx. Okay, dv dx. So when you differentiate, becomes 4 raised by x. Then we minus 1 from 4, and that gives us 3. Okay, and okay, this is plus. Please don't forget this is plus, right? This is plus 30. So the differential of a constant, whether it is plus or minus, will still give us 0. Okay, so we have gotten what we are looking for. Then it is time for us to apply our normal formula. And what is the formula? The formula is y equals uv. So if y equals uv, then we have we have a dy dx with respect to x is u dv, okay, dv dx, then plus v du dx. Remember, we are using x because x is a variable here. It can be t, it can be du dt, it can be du d, anything that's available as a term here, right? So that's what we're going to use here. So now we are going to what? Apply this. Okay, let's now appreciate this formula by using it to solve this problem. Now we are going to write u. What's our u? Our u is 3x raised by 6 minus 10. And that's, we're going to open our bracket and write 3x. All right, 3x raised by 6 minus 10. Okay, then dot. We are going to get our dv dx. So what's our dv dx? So we'll check our dv dx. Our dv dx is 4x raised by 3. So we're going to write 4x raised by 3. So this is our dv dx. Then we are going to add it to our v. Our v is x raised by 4 plus 30, and that is v here, x raised by 4 plus 30. So we're going to open a bracket and write x raised by 4 plus 30. So this is our v, and then we multiply by du dx. So let's go find du dx. Now this is du dx. Du dx is 18 x raised by 5. So we're going to put dot here. All right, 18 x raised by 5. So this is what we have for the substitution. So we have substituted. What we are going to do next is to simplify. Okay, how do we simplify? We can clear the brackets. Okay, when we clear the brackets, what are we going to get? Here we have 3. Use the 4 here to multiply everything here. Okay, use the x is about 3 here to multiply everything here. Do same here. Then we add up together, eventually arrive at our answers. So let's begin by clearing the bracket. We we have 3 times 4 is 12. Okay, then x raised to the power 3 times x raised to the power 6 is x raised to the power 9. Okay, then minus 10 times whatever we have here, just 10 times 4, which is 40. We have 40, then x raised to the power 3, then plus here we have 18 times x raised to the power 4. Okay, nothing is here, we just have 18, no number is there. Okay, then we have x raised to the power 5, then x raised to the power 4, then x raised to the power 9. Just use the law of indices and add up the powers. We'll get x raised to the power 9, then plus. Here we have just 30 here. Just bring in the 30 here, and we are going to multiply. Okay, multiply 30 by 18. So what is 30 times 18? Just 3 times 18. 18 plus 18 plus 18 was 18 plus 18 plus 18. All right, 18 3 times will give us 24. Right, 4 carry 2. Okay, then we add up this. Okay, that will give us 5, and this is 5. Right, 5. That's 54. This is 54. So this is what we have here. So we have 18 times 3 is 54. So we write 54. Then don't forget we have 30 here, and that is x raised to 5. X raised to 5. So in this case, we are going to bring in similar terms and add them up. We can see here we have 12x raised to 9 and 18x raised to 9. So we are going to bring them similar terms together. We are going to have 12x raised to 9, then add up with 18. We have 18 x 18x raised to 9. Then here we have plus 540 x raised to 5. Okay, then here we have minus 40 x raised to 3. So this is what we have in this stage.